tonight，想告别后来的他没在什么。
Good day everyone! I am Rosemary P. Bustamante from B.Ed 4A, and today we will be talking about the thoughts of some of the greatest scientists in history.
It is curious how often Arrhenius theories have had a beneficial effect for particular branches of science.
He meant that even incorrect scientific theories can drive progress. When a new idea is introduced, even if proven false, it often inspires fresh questions, investigations, and discussions. This process can lead to valuable discoveries or the development of new fields of study. In short, a mistaken theory can still play a positive role by encouraging growth and sharpening scientific knowledge. For example, the phlogiston theory in 1600s to 1700s claimed that a material called phlogiston was released during burning. Although this idea was incorrect, it encouraged scientists to investigate combustions and gases more thoroughly. These studies eventually gave rise to modern chemistry and led Antoine Lavoisier to discover oxygen and explain combustions accurately. Even as a false theory, it played an important role in guiding research that resulted in major scientific advances.
The important thing in science is not so much to obtain new facts as to discover new ways of thinking about them.
He meant that in science, the real progress comes not just finding new data, but from developing new perspectives or ideas to interpret that data. Sometimes, the facts are already known, but a fresh way of thinking can lead to breakthroughs and deeper understanding. In short, innovation in thoughts is as important as discovery itself. For example, the concept of gravity. For centuries, people observed that objects fall to the ground. This fact was well known, but when Isaac Newton introduced a new way of thinking by formulating the law of universal gravitation, those same observations gained a deeper, unified explanation. Later, Einstein reimagined gravity with his theory of relativity, showing it as the curvature of space-time. This shows how new ways of thinking about known facts can completely transform scientific understanding.
Nor must we forget that in science there are no final truths.
Claude Lévi-Strauss emphasized that scientific knowledge is never permanent or absolute. As science progresses, new findings and evidence can question existing ideas and lead to improved explanations. What we accept as truth today may change in the future as our understanding grows. In essence, a science is an ongoing journey of inquiry and improvement rather than a fixed set of final answers.
Of course, if one ignores contradictory observations, one can claim to have an elegant or robust theory, but isn't science.
Houghton R. meant that ignoring evidence that contradicts a theory makes it unscientific. A theory might look perfect or elegant, but if it dismisses or overlooks data doesn't fit, it stops being real science. True science requires considering all evidence, even the inconvenient parts, to refine or even change theories when necessary.
Science is a self-correcting process. To be accepted, new ideas must survive the most rigorous standards of evidence and scrutiny.
He meant that science constantly checks and corrects itself. For any new idea to be accepted, it must be backed by strong evidence and withstand careful testing and critical evaluations. This process ensures that only the most reliable and well-supported explanations become part of scientific knowledge.
Science, however, is never conducted as a popularity contest, but instead advances through testable, reproducible, and falsifiable theories.
Michio Kaku meant that science isn't about what's popular or widely believed, but about what can be tested, reproduced, and potentially proven wrong. Scientific progress depends on evidence and rigorous testing, not opinions or trends. A theory is only valid if experiments can support it repeatedly and if it can be challenged or disproven when new evidence arises. For example, the idea that the Earth orbits the Sun or heliocentrism, was once very unpopular and even opposed by authorities. However, scientists like Galileo and Kepler provided observations and calculations that could be tested and reproduced, eventually proving the theory true. This shows that science advances through evidence and reproducibility, not by what most people believe at a given time.
Science is not a heartless pursuit of objective information. It is a creative, human activity.
Stephen Jay Gould meant that science isn't just about collecting cold, objective data. It's also a creative and deeply human process. Scientists are curiosity, imaginations, and innovative thinking to ask questions, design experiments, and interpret results. In other words, science blends logic with creativity, driven by human passion and the desire to understand the world. For example, the discovery of the structure of DNA. James Watson and Francis Crick didn't just analyze data, they used creativity and imagination to model the double helix structure, building on the Rosalind Franklin's X-ray image. Their innovative way of interpreting data led to a groundbreaking understanding of genetics. This shows how human creativity and insight play a vital role in scientific breakthroughs, not just the raw facts alone.
Science begets knowledge. Opinion begets ignorance.
Hippocrates meant that true knowledge comes from science and evidence, while relying only on opinions or assumptions leads to misunderstanding and ignorance. In other words, facts and careful study lead to truth, but untested beliefs or guesses can keep people from truly understanding reality. For example, in ancient times, many believed that diseases were caused by evil spirits or curses, an opinion without evidence. This belief prevented real cures. When scientific study revealed that germs and bacteria cause many illnesses, doctors developed effective treatments like antibiotics and vaccines. This shows how science creates real knowledge and solutions, while relying only on opinion can keep people in ignorance.
It is a profound and necessary truth that the deep things in science are not found because they are useful. They are found because it was possible to find them.
J. Robert Oppenheimer meant that many great scientific discoveries weren't made for practical reasons, but simply because they could be discovered. Science often advances through curiosity and explorations, not just by seeking immediate usefulness. Later, those discoveries may turn out to be incredibly valuable, but at first they're often made simply because the knowledge was within reach. For example, when James Clerk Maxwell developed the equations describing electromagnetism in the 1800s, they weren't created for practical use. He was simply exploring the nature of electricity and magnetism. Decades later, those same equations became their foundations for technologies like radio, televisions, Wi-Fi, and modern communication systems. This shows that many discoveries begin with pure curiosity, and their usefulness is often realized much later.
In science, the opinions of 1,000 are not worth as much as one tiny spark of reason in an individual man.
Galileo Galilei meant that science is driven by evidence and reason, not by popularity or majority opinion. Even if thousands of people believe something, it doesn't make it true. A single idea, supported by logic and evidence, can outweigh widespread but unfounded beliefs. In science, truth depends on proof, not on how many agree with it. For example, for centuries, most people and even the church believed that the sun revolved around the earth. Galileo, using his telescope and logical reasoning, showed evidence that the earth actually revolves around the sun. Even though his view was unpopular and opposed by many, his reasoning and evidence eventually proved to be correct. This shows that, in science, evidence from one person can outweigh the beliefs of thousands. That concludes my video presentation. Thank you for listening. I hope you learned something. Bye-bye!